Let us now go to the next problem. It's a small numerical problem. The question is, calculate the weight of carbon 14, the radioisotope, whose half-life is 5730 years, which gave rise to 3.7 into 10 to the power of 7 disintegrations per second. How to work out this problem now? We know the decay constant. We know the decay constant K is equal to 0.693 divided by T half. This T half is actually given in terms of years. Therefore, we will have to convert it in terms of seconds. So, how will you convert that? 5730 into 365 days per year, 24 hours into 60 into 60. This is actually the value. The value of decay constant K is equal to 0.693 up to this value. This has been simplified to be, the whole thing when you simplify, this will work out to 3.84 into 10 to the power of minus 12 per second. Everything has been converted now into seconds. The number of years have been converted into seconds. Therefore, this will work out to 3.84 into 10 to the power of minus 12 per second. We also know another very important thing, that minus dN by dt, that is the number of atoms or number of particles, radioactive particles, is equal to K times N, where N is the number of atoms or number of particles present at a time t. This minus dN by dt, the most important things are N and T, where N is the number of particles present after a time t. T may be in seconds or years, as the case may be. We are now converted in terms of seconds. So, N is equal to the number of particles that are present after time t will be given by, this is Avogadro number, 6.02 into 10 to the power of 23 divided by 14. This is actually the weight of carbon 14 into W. Now, we also know this value is given. The number of disintegrations per second, which is 3.7 into 10 to the power of 7 disintegrations per second, is equal to, that can be given as this value, that is 3.84 into 10 to the power of minus 12. This has to be used. Then 6.02 into 10 to the power of 23 divided by 14 into, divided by 14 into W, that is the weight. The only unknown term that is found is only the weight. So, the N value we are equating. The value of N is already given here. The data is given here. Calculate the number of disintegrations are already given there. N. The number of particles per second is equal to, given there, 3.7 10 to the power of 7. This is equal to, this we have arrived at by means of this calculation from the decay constant. And the other values are all substituted. The only unknown value is W. That is actually what is asked for. Calculate the weight of carbon 14. Therefore, this weight on simplification works out to be 2.24 into 10 to the power of minus 4 grams. So, this is actually the answer for this particular question.